Under 6.2, we are told that you can add vectors and represent vectors using line segment. And there are some few fundamental facts about vectors that we should know even before we move forward. That a vector can be represented as a directed line segment. And the direction of the line is the direction of the vector. And the length of the line represents the magnitude of the vector. Of course, when you have vector, when you have a line that is connecting point A to point, this is point A and this is point B, then you can call that vector A, and the magnitude of the line, or the size of the line, is the magnitude of vector A. Point number 2 to note, two vectors are equal if and only if they have the same magnitude and the same direction. If and only if they have the same magnitude and the same direction. That could be C, D, and this could be vector C. So they have the same magnitude, the lines are of the same size, and they have the same direction. So we can easily say that vector A is equals to vector C. Point number 3, two vectors are parallel if and only if they have the same direction. They just don't have to be equal, but the fact that they have the same direction, we could have vector D and vector E. The fact that they have the same direction, then D is parallel to E. Point number 4, you can add vectors using the triangle law of addition. Triangle law of addition simply says, if you have vector A, point A to B, and then we can have another vector joining point C, then you can easily have vector AC is given by from here to here, because this is the original, the point of origin, and this is the point of termination, or where we are headed. Instead of following a direct route from A to C, then you can say AC is equals to AB plus BC, and all these are vectors. That is the triangle law of addition of vectors. Let us quickly go to example 3 and find out what we are expected to do in an attempt to use all this information that you have acquired now here. And before we go to example 3, it is important to highlight or to say that vector is simply explaining movement. So there is always a point of origin and there is always a point of termination. And example 3 says OACB is a parallelogram. OACB is a parallelogram. So we have it that way. The point PQM and N are midpoints of the sides. So we have those, this is A, this is O, this is A, this is C, and this is B, and then this is P, this is D, and this is Q, and this is point M, and this is point N. They are midpoints of the sides. OA is A, this vector OA, this vector is A, OA is A, and of course OB is B, so this vector OB, this is vector B from O to B, vector B. Express OC, AB, QC, CN, and QN in terms of A and B. Let's start with OC. Express OC in terms of A. And of course, we are moving, or we are walking from here to here. So we can say OC is equals to OA plus AC. But OA is A and AC is parallel to OB, and therefore OC is equals to B. So OC is A plus B. The next vector is AB. Let's talk about vector AB. How do we talk about vector AB? Vector AB, we're walking from here to here, and we can easily walk that way, then drop that way. Or we can walk that way and then walk horizontally that way. And this is the most, the one you'll understand easily. So A plus, it's AO plus OB. And of course, AO is the opposite of OA. And in vectors, the opposite direction is explained by the negative side. So this one is going to be minus A plus B, which is also equals to B minus A. That is as far as vector AB is concerned. What about QC? Vector QC. Where are we starting from? We are starting from here, and then we are headed there. QC, point P, Q, M, and N, we were told that they are the midpoints of the outer sides. So Q is the midpoint of AC. That means vector QC is half of vector AC. So QC is half of vector AC, which is actually, and AC is OB, which is a half B. That is as far as QC is concerned. What about QN? What about CN rather? What about vector CN? Vector CN is a half of vector CB. And CB is the opposite of A, or rather, it is AO. CB is the same as AO. Remember, we are told the whole diagram is a parallelogram, and therefore opposite sides are parallel and equal, meaning that CB is equals to AO. So this is simply minus a half A, because that is minus a half A. What about vector QN? QN, vector QN. QN is QC plus CN. And what is QC? We have QC here, which is a half B plus CN, which is minus a half A. That is QN. Because we have already combined, QN is QC plus CN. And QC is a half B, and CN here is a minus a half A. So this is vector QN. That is as far as point A is concerned, or part A of the question is concerned. What about part B? What can you deduce about vector QN? What can you deduce about vector QN? If you look at QN, vector QN, that way, that vector, which is a half B minus A. Is there another vector that is written in terms of B minus A? Yes, there is another vector which is written in terms of B minus A. So QN, you can see, is a half AB, because AB is B minus A. A half AB. That means what? Because QN has been expressed as a scalar multiple of AB, being expressed as a scalar multiple of another vector expresses or shows that the two vectors are parallel. If you multiply both sides by 2, you'll find that 2QN will give you a whole vector AB. That means if you put two vectors of Qn together, they will give you 1AB. And that means because we have been able to express the two vectors as scalar multiples of each other, then Qn is parallel to AB, or rather the two vectors are parallel. That is exactly what we can deduce from Qn. So if you can use Qn moving that way and AB moving that way, it may not seem clear diagrammatically because our diagram is not drawn to scale, but of course from what we have said, you can already see it here that Qn is parallel to vector AB. All right?